Okay, so like I said, our goals today, one, we want to talk about the quiz if you have any questions. Two, we'll go ahead and dive into the sinusoidal modeling assignment if you have any questions on those. Just a few housekeeping items before we go ahead and get started. If I can find my list here. Okay, so today we're talking about the homework. Remember, tomorrow you've got a quiz over sinusoidal functions. Okay, writing the equations, sketching them, finding the elements, the period, the amplitude, all that good stuff. So please take some time to go ahead and look that over prior to the quiz tomorrow. Waivers, progress reports are going to be passed out during 7th period tomorrow, but if for this class or any other you need a waiver for an extracurricular activity, go ahead and take care of that as soon as possible, because I believe the deadline is tomorrow by 2 p.m. So Mr. Young says he's not going to be available on Friday. So if you don't get the waiver signed, then you don't have until the end of the 9 weeks to go ahead and get you back on the sports team or whatever it is that you might be using. Okay. Now, especially for this class right here, when we start inverse trig functions, which I don't believe we'll need this until Monday, so that gives you a little bit of time. But for a class this size, unfortunately, I do not have enough protractors for everybody. So please, 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 if some people would go ahead and make sure to buy themselves a protractor, my advice is to make sure that the straight edge is a ruler as well. Okay, but you're going to need a protractor come Monday, okay, for the lesson that we're going to be doing. And if you don't have one, if I run out, you kind of have to go ahead and, do the best you can, and we'll see what happens. All right. So the only other thing I need to go ahead and make sure that you're aware of, next Wednesday is what? No, that's Thursday. That's next Thursday. Next Wednesday is the second exam. Okay, so it's going to be covering 3 lessons. It's going to cover the 2 graphing lessons, the one where we focused on sine and cosine, the other one where we focused on the other 4, and then the third is going to be the sinusoidal packet that we just finished up yesterday and we're talking about right now. Okay, so you will be allowed a 3x5 note card. I've got those ready to go. I'm thinking Friday is when I'll go ahead and pass those out. You can start to look at that over the weekend. But keep in mind, 2 weeks from this Friday is what? The end of the first 9 weeks. So these last grades are going to be really, really important, especially if you may be one of those people who are kind of worried about your average. Okay, so questions. All right, well, let's take a look at the quiz. So I went ahead and worked out number 1 ahead of time. Okay, so horizontally, I started my inequality between negative pi over 2 and pi over 2 because we're graphing tangent. What did I start with if I want to graph cotangent? What were the values of my inequality if I want to graph a cotangent? Edward. Okay, somebody help Edward out with the question. Okay, Max, go for it. 0 and pi. There we go. Okay. Well, what 2 trig functions am I going to use if I want to graph with 0 and 2 pi? That's sine and cosine. Okay. Now remember, tomorrow you're not going to have a note card or anything like that. So you want to make sure that you spend some time looking over the material. Next week you will have the note card. So definitely put the little stuff on there. Maybe it's the inequality here. Maybe it's the vertical values. Maybe it's the formulas for your items. Whatever you think is going to be most beneficial to you. All right. So were there any questions on number 1? How I got anything? Give. Well, let's say, like, for example, there's a couple of ways that you could approach that. Let's say if we had a fraction that we're dividing by 4, like, I don't know, maybe 2/3 divided by 4. You can still apply the rule. So if whatever you're dividing by isn't a fraction, we can go ahead and make it a fraction by just putting it over 1, so that I can still apply the rule of multiplying by the reciprocal. So this would be 2/3 times 1/4, which is going to be 2/12 or 1/6. Okay, so you can still apply that rule if you want to. All right. So anything, whoop, didn't get up to the top there. Anything about number 1? Nope. Hey. All right. So moving on. What about number 2? I think I caught several people on number 2. Remember, tangent, cotangent, secant, cosecant, they don't have what? There's no amplitude because they're infinitely high. Remember, we have the formula, the absolute value of A. A is 2. A lot of people put 2, but remember, they don't have an amplitude. There is no maximum value. Okay. Is there anything else on number 2? That was just the biggest issue I saw right there. Okay, so the period. Okay, so this is a good problem to practice with. So looking at this function here, 2 cosecant of 4/3 x minus 1, would everybody agree that A is 2, B is 4/3, C is 0, and D is -1? Okay, would everybody agree with that? Okay. And which one were you asking about specifically? The period? Okay, so let's see. Peter, what's the formula for the period of a function? 2 pi over b. So in this case here, I'm going to take my formula. I'm going to go ahead and plug in my value of b, which is 4/3. We were just talking about multiplying by the reciprocal. So 2 pi over 1 times 3/4. So that's going to give me 6 pi over 4, which would be 3 pi over 2. Okay, now what is the reciprocal of the period? What other item has that relationship? It's the frequency. So we know the frequency is b over 2 pi, but if I already have the period, well, then that would just be 2 over 3 pi. The graph should repeat itself twice within a 3 pi interval. Okay, Gabriel, is that good? Okay.
If you're able to cross multiply, like how it take off the 2 and then the 4.
Now you're not cross multiplying, you're cross simplifying. Because see, what divides both 2 and 4? Well, it's 2. So 2 goes into 2 once, and 2 goes into 4 twice. So that's where I got the 3 pi over 2. Okay, so we're not multiplying, we're simplifying. Okay. And were there any questions on number 3? Okay. So let me go ahead and show you how we can kind of work number 3. Here's how I did it. And the fact that we have, number 1 where we're graphing tangent really kind of helps us out. Remember, we start off tangent. Does it curve up to the right? Or does it curve down to the right? It curves up to the right. Okay, well, if we take a look here, all of these functions are curving up to the right. So that means at least those branches look the way they're supposed to. Okay, as long as I'm comparing them to the original. So that means that my value of A has to be positive. Now, if it were negative, then it would flip it. They would be going down to the right like cotangent. So I can eliminate any answer where A is negative, A is less than 0. So right there, based on that, I've already got it down to a 1 in 2 shot. So now we got to figure out what's the value of B. Okay, now think about when we look at this graph horizontally, our first pair of asymptotes is always going to be between negative pi over 2 and a positive pi over 2. Okay, so where are my asymptotes now? Okay, looks like they're at a plus and minus pi over 4. So what happened horizontally? Did the graph stretch or did the graph shrink? The graph shrunk. Now here's what's really, really important. When we multiply x by some number, what's the key word? Starts with R. The reciprocal. Okay. So I should have gotten a smaller number when I take the reciprocal. So what does that mean? Does B have to be greater than 1 or is B less than 1? B would have to be greater than 1. Like, for example, we don't know anything. Let's go ahead and say that we had tangent of, for example, 5x. Okay. Well, the reciprocal of 5 is 1/5. See, that's going to result in a horizontal shrink. So the only way we can get a horizontal shrink is if we started with a value of b bigger than 1. If it was a horizontal stretch, then we would have started with a b less than 1. But of course, bigger than 0. Okay.
So if the positive is squared, then
One more time.
okay, so if it's spacing like that, it'll be a greater than 0.
Yeah, so if it looks like what the original graph did, if it curves up to the right, that means there's been no reflection. So A would have to be positive.
And if it's how it's like negative pi over 2, so how would it be like a squared, then how it would be greater than 1?
Because of what I just said right here. Okay. Because we know that this graph was shrunk horizontally, this is where my new asymptotes are going to be. I need something bigger than 1 because the reciprocal tells me it's going to shrink. If I put in something like this, tangent of, let's say, 1/2 x, okay, b is 1/2, what's the reciprocal of 1/2? 2. So the reciprocal being 2, this tells me that I'm going to stretch it horizontally. This is the easiest way to remember it. Whatever the reciprocal does, if it becomes a smaller number, it's a horizontal shrink. If it becomes a bigger number, it's a horizontal stretch. So because this shrunk horizontally, I know I have to be dealing with a bigger number.
If it shrinks, it's a small number.
If it shrinks, b has to be bigger than 1. So the reciprocal would be less than 1, and vice versa. All right. So if anybody's wanting to retake that, because we had a short week, you have until this coming Monday morning. Monday morning by the end of tutorials 8:05. You just have to have the assignment turned in prior to that. I know we took it last Friday, but I'm going to go ahead and extend it because of the short week. Also, I don't want to forget, I do apologize if anybody was going to come in yesterday and for afternoon tutorials. Unfortunately, I had to cancel them because I'm sure you heard about the lake that was outside in the hallway. So, but it's all clean now. So I'm here after school today, unless something else happens. So hopefully not. All right. So let's go ahead and turn our attention to the assignment. Okay. And what is the first question we want to talk about? 7. Let's do 7. Let's see here. Where is my paper? Here we go. Okay, so number 7. Okay, so a piston operates by a wheel rotating at a constant rate. Now, that's not W, that's what? Omega. There we go. So radians per second. The back and forth motion of the piston is an example of simple harmonic motion. In a mechanical piston, like the one shown at right, a wheel with a 6 centimeter radius turns with an angular velocity of 6 pi radians per second. All right, so part A says, what is the frequency of the piston? All right. Well, we already know a couple of things. We know that omega has to equal what? Can anybody tell me? It's got to equal just 6?
6 pi.
6 pi. Okay, now, we haven't really gone into this in a whole lot of detail, but angular velocity, that's the speed at which an angle is moving with respect to time. It's very much tied to linear velocity, like the speed of anything circular. Normally, I usually teach that pretty early in the year, but I don't know if it's going to be on the AP exam, so that may be something that we don't talk about this year. But the angular velocity is always going to be in radians per second. So let's say even if you didn't have, that background knowledge, okay, well then we're told omega radians per second, and then we're given this 6 pi radians per second. Okay, so we can go ahead and make the connection that, yeah, omega has to be that 6 pi. Okay, everybody's okay with that? Okay, all right. So what else do I know? Do, do, do. What's it asking me for? It wants the frequency. Okay. So what was the formula for the frequency? Okay. Oh, careful. Now remember, I don't want to split hairs on these particular problems, but with harmonic frequency, remember they just changed the formula. They replaced B with omega. Okay. So you got these two formulas here. So 2 pi over omega, that's going to be the period. Okay. And then omega over 2 pi, that was going to be your frequency. Is everybody okay with that? So in this case here, I mean, go ahead and put it in the tray. So if you were to go ahead and replace it with B, I mean, there's no harm or anything, but I'm just going to go ahead and stick with omega because that's what the problem is using, and I don't want to confuse anybody. Okay. So we know what omega is. We have a formula for that. So what's my frequency? Yeah, it's just 3. Okay. So I'm just going to go ahead and plug it in. So right there, I'm going to plug in my 6 pi. So 6 pi over 2 pi, the pi's cancel, 6 halves, there's your 3. In fact, can anybody tell me what the period is? 1/3. Remember, what's the relationship between the frequency and the period? They are reciprocal. So if I know one, I automatically know the other. Okay. So part B, it says, what's the distance from the starting position, t equals 0, exactly 2.4 seconds after starting? Okay. Now remember, there were two formulas here that we were going to go ahead and use. So d is equal to a cosine of omega t versus d is equal to a sine of omega t. Which one's going to be more appropriate to use? Should I use the cosine or should I use the sine? Okay, who said cosine? Okay, Kia, why? There you go. Remember, that's the key difference. You can always rewrite these functions using either sine or cosine. It may include like a reflection or a phase shift, but to make it easy, if your item, whatever it is you're describing in the problem, starts at a maximum or a minimum, we're going to use cosine. So here it is starting the maximum distance from the piston. Is everybody okay with that? If it starts at the origin, then we're going to go ahead and use sine. Now, sometimes they won't always go ahead and say origin. They might say something like at rest. That's just another way of saying at the origin. Okay, so absolutely, we're going to go ahead and use this one right here. Well, I've already got omega. We know that that's 6 pi. Okay, do we know what the value of A is? What's the only other value they provide me in the problem? A has to be 6. Okay, so here's my function. D equals 6 times the cosine of omega was 6 pi t. So there we go. So now that I have the function, I can go ahead and answer the question. So what's the distance from the starting position t equals 0? Exactly 2.4 seconds after starting. Okay, so what am I going to do here? How would I answer the question, Gabriel? There you go. I'm going to take that 2.4. I'm going to go ahead and plug it right in there. Okay, so try that for me. See if you can figure out what the answer is. I'll come back up here and just say it in a second. Okay. Now, think about what the question is asking. Okay, this one's a little tricky. You might be thinking, how's it a little tricky? I'm just going to plug in t equals 2.4, right? That's the first part. Okay, then you got to do something. Okay, so on Wednesdays, we get out of here at 25. Okay, we're still got 20 minutes. We're doing good. We're doing good. Right, Cameron? Right, Cameron? Okay. All right. Okay, so everybody thinks they got the answer? Okay. Here is your answer. 4.15. Okay. So some people, I'm seeing the look on their faces, they're like, oh, okay. And then other people, I'm seeing the furrowed brows, like, what the heck just happened? Okay, so let's start with the first step. We do need to plug 2.4 into T, right? Okay, so I'm going to come on over to my calculator. So let's see here. You definitely want to make sure that your calculator is in rads. Okay, so 6 cosine. I have 6 pi times T, which is 2.4. Okay, so I'm getting 1.85. So where did I get the 4.85? What's that, Ken? We had to subtract. Okay, so 1.85 is what the function gives me. Oops. Okay, but I have to go ahead and subtract it from 6. Okay, now here is where I'm going to hopefully help you out. Okay, look at what the question says. What's the distance from the starting position when t equals 0? 2.4 seconds after starting. So I want you to take a difference of these two right here. Okay. In fact, if I were to go ahead and plug t equals 0 in the function, let's see what happens. Come on over here to my calculator. So I'm going to do the same thing, and I'll go ahead and remind you of this. Instead of retyping the entire expression, use your touchpad, highlight it, just push enter, and then all I got to change, is one little part of it. So I want to go ahead and replace t equals 0. 6. Okay, so from the time when t equals 0 it first started to 2.4 seconds, how far did it move? Is everybody okay why I had to subtract? That one was kind of tricky just because of the way they asked it. Yeah, because that's what it gives me in the problem. So if I come on over here, take a look, okay. See, what's the distance from the starting position when t equals 0? Oh, my screen had a seizure. Okay. T equals 0, 2.4 seconds after starting. So basically, it wanted me to evaluate both of those and take the difference so I know exactly how far it moved. So in this case, it was 4.85. I believe we're in centimeters? Yes, centimeters. Okay. Well, that's about number 7. Okay. Is that good? Okay. All right. What else? 8. Okay. Let's take a look at 8. So it says a weight oscillating up and down on the bottom of a spring, assuming no air resistance or friction, can be modeled as harmonic motion. Okay. If the weight is displaced a maximum of 8 centimeters and it takes 2 seconds to complete one cycle, what's the frequency of the oscillating weight? Okay. So in part A, I'm trying to find the frequency. Okay. What do we already know? Okay, so we do know that when they say in a problem that an object has been displaced, they're telling you what the value of A is. So I know that A is equal to 8, okay, but what's 2? How do we know that's the period? It takes 2 seconds to complete one cycle. So they use different ways of saying this. They might say complete a cycle, 1 revolution, things of that nature. Okay, so I know the period equals 2. Okay. Well, I don't even have to use a formula if I don't want to. What's the relationship between the period and the frequency? They're the reciprocals. So the frequency would have to be 1/2. So I'd have to see one cycle in 2 seconds. So it's going to repeat once every 2 seconds. Now, if you did want to go ahead and run with the formulas, remember we saw these on a previous problem. We know that 2 pi over omega, that's going to be your period. We know that omega over 2 pi is going to equal your frequency. Okay. Well, we already know that the period equals 2. So let's just work backwards. So if 2 pi over omega is equal to 2, let's solve that equation. So I'm going to multiply through by omega. Okay. So 2 pi is going to equal 2 omega. Divide through by 2. So this tells me omega is what? Not 2. Omega is pi. Would everybody agree with that? So I know omega is pi. Well, let's go ahead and plug it in this formula here for the frequency. So 2 over 2 pi. Oops. At least I caught myself. That would be pi over 2 pi. Excuse me, I plugged in the wrong number. Okay. So the pi's cancel, and you still end up with what? 1/2. Okay. So, there's a couple of different ways. If you knew the relationship ahead of time, you have the answer immediately, or use the formulas. Okay. Now, take a look at B. Find the modeling equation if the action of the spring is at the origin when t equals 0. So here's what we know so far. We already know that A is what? A is 8 centimeters. That's the amount of space that was displaced. Okay. And by going through this, we already found that omega equals what? Omega equals pi, right? Okay, so I'm going to let you folks decide for me. Remember, with harmonic motion, you've got 2 choices. You're either going to have d is equal to a times the cosine of omega t, or you're going to have d is equal to a times the cosine of, I wrote the exact same thing. Oh, I'm on the ball today. Sine of omega t. What about the problem makes the choice for me? Gabriel? It's not cosine. Okay, take a look at B. Find the modeling equation of the action if the spring is at what? The origin. Remember, that's the key difference when deciding whether to use cosine or sine. If you know for certain you're starting at a maximum or a minimum, definitely use cosine. If you're starting at the origin, use sine. So in this case here, I'm going to use this form. I've got my A and omega, so we just plug in. D equals 8 times the sine of pi t. And there we go. So that should be able to model this right here. How are we doing? Gabriel. This material. This is what the quiz is tomorrow. These kind of problems. So I'll go ahead and give you a heads up. I pulled pretty much all of these off of College Board. So there's 5 problems. Okay. All are multiple choice, I believe, except one. All right, so hopefully that'll help out. Maybe multiple choice. Basically, yeah. That's okay. We like word problems. Word problems make the world go round. Okay, well, we get out of here at 25. We still got enough time for another one. Hey, Hannah. Oh, I thought you went like that or something. 10? Let's take a look at 10. Okay. Okay, now 10. So it says a weight is attached to the end of a long spring that's bouncing up and down. As it bounces, the distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reads 0.4 seconds, the weight first reaches a height of 72 centimeters above the floor. The next low point, 48 centimeters above the floor, occurs 1.9 seconds later. Okay. So this one here, not only are we going to go ahead and write the equation, we have to decide whether to use sine or cosine. And again, I can't emphasize it enough. I can actually write the equation using either one. But what do you think is more appropriate here? Is it more likely that this thing is occurring at a maximum or a minimum, or it's going to occur at an origin? I'm thinking a maximum minimum. So I would use what? We're going to use cosine. So I'm going to make sure that my function looks like this. So I'm going to say A times the cosine of bx minus c plus d. That's a b right there. Now, what are they giving me in the problem? Like, for example, do I already have the max and the min? I do, right? What's the maximum? Okay, so the maximum height is 72. Okay, what's the minimum? 48. Now, if you already know the maximum and minimum, there are two parts to this equation we should be able to get pretty quick. What am I referring to? The amplitude and the midline. Okay, so let's say I want the amplitude. Not plus. There we go. If I want the amplitude, I'm going to take the maximum minus the minimum and then divide by 2. Okay, and if I want the midline, this is when I'm going to add them. So that would be the maximum plus the minimum divided by 2. All right, well, let's go ahead and plug those in. So let's see, 72 minus 48 divided by 2. Okay. So 72 minus 48 would be 24. Half of 24? 12. So see, right there, I've already got one part. Okay. All right. So see if you can go ahead and figure out what the other one is. What variable is the midline associated with? That's D. Okay. That's D. So this time I'm going to need a 72 plus 48, and then half of that. So what is D? It's 60. Half of 120. Okay. Right there, we've already got half of what I need. Okay. Now, if I find B and C, we've got the hardest part of this problem over with. Okay. Because then B, C, and D, all I'm doing is just answering questions based on the equation that I created. Okay, so let's talk about B. Now, we've seen this before. I can only go ahead and figure out B if I know what? The period. Can anybody tell me what the period is? Now, the period is going to come from your time. They're giving you clues here. We know the first maximum occurred at 0.4, and we know that 1.9 seconds after we started, we reached the minimum. Okay. Kia, you put what? Say that louder. Be more confident. That is right. You don't know how you got it. Okay. How many people got 3? Okay. Here's the thing. Let's take a look at this graphically, right? Okay. How are we doing on time? We got 5 minutes. We got this. Okay. What function did I start with? We chose what? We chose cosine, right? Okay, so let's look at the graph of cosine. Let's see if this can help me out. So cosine's going to look probably, something like this. Okay. Now, in this one, we already know there's going to be a shift because after I start the time, you hit a what first? You hit a maximum. It's maximum height. So I know that this graph right here is going to have to just kind of shift over. Okay. So here's the thing. All I know is that at 0.4 seconds, it reached its maximum height of 72. Okay. But that 1.9 includes this 0.4. Okay. 1.9 seconds. So after we started here, to get to that first minimum, this was 1.9 seconds. Okay. So how much time was there between when it hit the maximum and when it first hit the minimum? How'd you get that? You subtracted, right? Remember, what do we know more than anything about these graphs? They're what? It starts with AP. They're periodic, right? So if this right here is 1.5 seconds, how long would it take to get back to another maximum? 1.5 seconds. So our period is 3. Now I can work backwards and go ahead and figure out exactly what my value of B is. So how have we done this many times on other problems? What am I going to set my period equal to? What's the formula? 2 pi over, now, and if you want to leave it as omega, you can. This isn't a simple harmonic problem, so now we're okay going back to B. But again, omega wouldn't change anything. Okay, so if I go ahead and set that equal to 3, okay, what's B? What's what? 2 pi over 3. Okay, all right. Now here's the thing. I'm going to go ahead and put together everything we've got so far. We've got 3 out of the 4 values I need to write the equation. Okay, good so far? Okay. So let me go ahead and get all this out of the way. Okay, so here's what I got. Y equals, we found A to be 12 times the cosine. Now here's what I'm going to do. I'm going to take this value of B. I'm going to write it factored out. Okay, because I want to talk specifically about the phase shift. So I'm going to go ahead and put 2 pi over 3. Okay. And then I'm going to say x. Now think about what I did with this graph here. Did I shift it right or left? I shifted it to the right. So what does that mean? Plus or minus? Minus. We take the opposite. So I know it's got to be minus something. And then we found out that the midline was 60. Okay. Anybody think they know what is my phase shift? How far would I have to shift it over? This one, there's no trick. They give it to you. It's 0.4. Now, you remember how we've done on the other problems where we've been determining that we've been shifting it a quarter of the entire period? So we've been multiplying the period by 1/4. Well, here we can't say definitively that 0.4 is 1/4 of the period. Okay. In fact, what is 1/4 of 3? So 3/4, so 0.75, right? So that doesn't work here. So all I know for sure is that when they went ahead and started the timer, okay, it took 0.4 seconds to get to that first maximum. Okay, so here's my equation. Okay. Now, like I said, that was the tough part. Now B, C, and D, all you're doing is answering questions. Like, for example, B says predict the distance from the floor when the stopwatch reads 8.4 seconds. What are they giving me? What does 8.4 represent? 8.4 what? Seconds, right? So the only 2 quantities I have in here is either time or the height of the object. Well, they're giving me this, so that's got to be x. So I'm just going to go ahead and plug it right in there. Okay. Part C says, what's the distance from the floor when you start the stopwatch? What value of x would I plug in for that one? 0. Now, I won't be able to show you this because our time is almost up, but for part D, it says predict the first positive value of time where the weight is 55 centimeters above the floor. So they're not giving you time, they're giving you what? They're giving you the y value. They want you to go ahead and set this equal to 55, then just find the intersection in the calculator. Okay. All right. Well, thank you, folks. Have yourself a great day.